So here we're going to be looking at functions of random variables. And again, this kind of relates back to expected value stuff and the e of x. That's the expected value. But here we're looking about doing some mathematical stuff. When we want more than just the expected value, we do some combinations with it, or we apply a multiplier to it, we do something to it. A couple things I just want to remind you real quick. Your variance of a random variable is equal to the standard deviation squared. So variance of x is equal to the standard deviation squared, which also then relates us back to this idea that the square root of the variance is equal to the standard deviation. That becomes important for us because we often have to switch back and forth between standard deviation and variance as we're going through these problems. Now, these formula here, they will be given to you on your formula sheet, so you don't need to worry about memorizing them. And before I even really explain what it is, let's just get into a problem, and in context we'll make sense of the formula. So, if we take a single random variable and multiply it by something, or add a constant to it, that's basically what we're doing. We're taking a random variable of x, we're multiplying it by something, and then adding another thing to it. So as an example here, x is the number of occupied rooms in a motel complex. So this is our random variable. How many rooms in a particular night, I guess. And so we see here there's 1, 2, 3, 4, 5, or 6 rooms that are occupied. And this is our probabilities. So in this case, first thing we have to do is figure out our expected value and the standard deviation. And you might remember this with your calculator. And in this case, we want to go into stat, enter in our numbers. We have 1, 2, 3, 4, 5, and 6 rooms that are available to us. Probabilities. Alright, now once you've got that entered in, remember you go calc, variable 1, but before we do that, let's go and set and make sure that this is list 1, and that needs to say list 2. Now we can do variable 1, and this will calculate for us our mean and our standard deviation, which are those two numbers there. So remember the mean, that's always the x with the bar over it. And the standard deviation will be this one here. Yours might just say sigma x, depending on which version of the calculator you have. But your mean will be 3.55, and your standard deviation will be 1.43. And because I know something from experience, I know that for my next calculations, I'm going to have to take that standard deviation and turn it into a variance. So remember, sigma is the standard deviation, and if I want the variance, like I said, the variance is equal to the standard deviation squared, so it's going to be equal to 1.43 squared, and that gives us 2.045. And that will become important for us as we go through the problem. So the motel cleaner is paid $30 per room, plus an extra $25 per day for travel. Use the distribution for the cleaner's income in a day to find out the expected value and standard deviation of the cleaner's income. So this is the expected distribution of the number of rooms that will be available on any given day. And so we know our expected value is 3.55 and our standard deviation is 1.43. So this is for the number of rooms. There's on average going to be 3.55 rooms occupied at the hotel. So I'm trying to calculate something new here. This is for the rooms, but what I want to do is find something for the cleaner's income. So this is something new. If you want to think about that, that's E of rooms if you want to put in words instead of just variables to look at. So the cleaner's income, that's going to be equal to, well, the expected number of rooms cleaned in a night, which is $30 times each room that's cleaned every night, plus the $25 a day for travel. So if I rewrite this, just abbreviating some things, let's change that to an I. So the expected value of her income, or his income, is equal to the expected value of 30 times X, which is our number of rooms, plus 25. So if we look at our formula, what we're looking at here is an expected value of 30 times the number of rooms plus the 25, and that's going to convert using our formula to say 30 times the expected number of rooms plus the 25 per day. So this 30x plus 25 becomes 30 times the expected number of rooms plus 25. And we can plug into our formula here because we know that. So 30 times the expected number of rooms, which is 3.55, plus 25. And this gets us to 131.50. And that is the expected income per day for the cleaner. So again, we can call that E of I. So I've taken this idea that the cleaner's income is based on $30 for every room plus $25 a day. So I know that on average I expect 3.5 rooms a day, so that's 30 times 3.5 plus the $25 a day. Now the next part of this question is to get the variance. So the variance of her income is going to involve the similar sort of situation here. That's the variance of $30 times the number of rooms plus the $25 per day. And when I use the formula given to us here, that's 30 times the number of rooms plus $25 per day. You'll notice here it becomes 30 squared times the variance. And we no longer see the b, that goes away, it gets dropped. So this is going to convert to be the variance, 30 squared times the variance of x. When we leave the 25, it goes away, according to the formula. So that's going to be 30 squared times 2.045. That'll be equal to $1,840.50. And to get to the standard deviation, which is our next step, we need to do the square root of 1840.50, which will get us to $42.90. So that's our standard deviation. Now, pause for a minute here and pay attention to that because it's a common thing to forget. First thing I had to do was convert the standard deviation into a variance. So I have to go from standard deviation to variance. I'll use the variance down here, and then I have to convert back to standard deviation using squares and square roots to get between the two. So watch out for that. Make sure you're using the standard deviation or the variance according to what's needed in the formula. So a couple of things to watch out for here. When you add a constant, like we did $25 a day, it's got no impact on the spread, and that's why the b disappears off the right side of the variance formula. So here you'll notice the $25, we no longer need it in this variance for the income. And part of that is because timesing by the $30, that shifts things. Sorry, timesing by the $30 makes things bigger and much more spread out. But the plus 25, that basically, if you want to think about like the band, if that was the band of values, it just shifts. So that plus 25 just shifts the expected value, but doesn't change the spread. So it has no impact on spread. So that was for the plus 25. So that's the idea. Plus 25, it's going to shift it up or down, but it's not going to change how much variance there is, because every day they'll get $25 extra. Right. The second thing to notice here is the change of units. If this happens, you can use the formula in the table that are given to you, and that's with the a squared. Now, this will come up because in the next section, we look at situations where you have to use a formula that's not given to you, when you have to know. But here, straightforward, X was measured in rooms and I was measured in dollars. It's a change of units, going from rooms to dollars. So you don't have to think about much. You can just plug straight into the formula that are given to you and you're good to go. So one more example to look at here. The taco shop sells a mean number of 421 tacos a day with a standard deviation of 28. Each taco sells for $2.80. Find the expected sales and the standard deviation of the sales for the day. So already I know I'm talking about 421 tacos, but I'm looking for sales. That's a change of units from tacos to dollars, so I know I can use given formula. So let's think about what we've got here. My random variable here is the tacos, and the mean number of tacos is 421 tacos. My variance, well, I have to figure out what my variance is from my standard deviation. So the variance of x is going to be equal to 28 squared. That's your standard deviation squared. Okay, standard deviation of 28 tacos. And I'm going to square that for my variance. So I want to know the number of sales here, the expected sales and the standard deviation of sales. So what I'm looking at here is a situation here where I'm looking for the expected value, $2.80 times the number of tacos. There's not a plus term here like there was in the question above, where we also had an additional $25 a day. Here we're just looking at straight tacos, no extra constant added onto it, so it's just the $2.80. And this is going to be for sales. I guess, sorry, I might change that. You can probably write this in on the side, sales. That's the $2.80 times the number of tacos that are sold. So using our formula, if you go back up and look, E times the number of $2.80 per taco is going to be $2.80 times the number of tacos, and there's no constant in this question, so we can ignore the B. So that just becomes $2.80 times E of x, which is $2.80 times 421 tacos, which is going to be 1,178.80. And this is now dollars. So the expected sales is 1,178 and 80 cents. Now my variance, again, here you've got the interesting situation where you've got to remember to square it. So for the expected value, you just times it, but for the variance, you have to square it. So the variance of the sales is going to be equal to the variance of $2.80 times the expected value there, or the random variable variance. And this is going to become $2.80 squared times the variance of x. So that's $2.80 squared times the variance of x is 28 squared. I haven't changed that to a number yet. It's still just 28 squared. So when I do that, $2.80 times 28 squared, I get 6,141. But remember, that's your variance of the sales. and I want to know my standard deviation. So this is the part where you have to remember to convert back. So standard deviation is equal to the square root of the variance, and this is equal to $78.40. So my expected number of sales would be that, and the standard deviation of the sales will be that. One more example to look at, a random variable. So a random variable has a mean of 60 and a standard deviation of 5. Find the expected value and standard deviation of 2x minus 10. So this is kind of just a very, I guess, abstract problem. There's no context to it. We can just call our random variable x. So here I know that the expected value of x, its mean, is 60, and its standard deviation of x is equal to 5. So that tells me the variance of x will be equal to 5 squared, which is also 25. So if I want to find this, the expected value of 2x minus 10, that's going to be the same as saying 2 times the expected value of x minus 10, which is 2 times 60 minus 10, which is equal to 110. And for the variance of 2x minus 10, that's going to be equal to 2 squared times the variance of x. And we don't have that minus 10 there. The minus 10 gets dropped off. So that's 4 times 25, which is equal to 100. That's my variance. To get back to my standard deviation, take the square root of the variance, and you get 10. So the expected value is 110, the standard deviation is 10. So there's lots of problems to do with these. Key things to remember is just identify what your random variable is, anything that you're multiplying it by, and then anything that you're adding or not. And if that plus term isn't there, you can just ignore it. And again, these are the very straightforward problems. If you were ever in a doubt in an exam, just go for it. Just use the formula exactly as it is. But here we're actually changing a variable. For instance, again, going from things like tacos to money, or in the question above, from rooms to income for a worker at a hotel. So give a go practicing some of these. Be sure to ask me if you have any more questions.